Welcome to Ray Engineering Mechanics. So, here is a question on force system. The question says the tie rod AB, this is your A, and then this is your B. This is the tie rod AB. So let's be doing this. Let's show this. This is our tie rod AB. So they said the tie rod AB exacts the 200 Newton force on the steering knuckle AO. It is being exerted on this force AO, on this knuckle, steering knuckle AO as shown. Replace this force by an equivalent force couple system. So that means, so we know from the definition of our couple, we know our couple, they have opposite direction but same magnitude. So that means if a particular force 250 Newton is acting here, so that means another force is acting here. It will also be 250 Newton. Also, it will be making an angle, since it is acting like this in this downward direction. That means it will be making an angle of 10 degree also in this direction. So since we've already identified that, now said at this particular spot, so that means if this one is going here, this one is going here. So what's left for us is to calculate the distance from this part. We should resolve this particular force about this particular point. Don't forget, we know our moment is equals to the product of force times the perpendicular distance. So we know our moment is equals to r cross f. You can use either of these two methods. So I will use this particular method, and you guys can also use this method where I give the explanation on how to go about this. So so let's start. So that means in this case we'll be having r cross f. So that means we have to write our f in terms of x and y component. So now, since as you can see, this will be more like how our force will be this will be more like how our force will be acting. One will be acting in this y direction, the other will be acting in this x direction. So that means for our y direction, we'll be having our f. Then don't forget, this will be, if the angle 10 degrees here, the x direction will be opposite, the y direction will be adjacent. So this will be f cos or cosine of theta. So while this one will be f sine of theta. So this one will be f sine of theta, this one will be f cosine of theta. This one is going towards the positive side, this one is going towards the negative side. So let's write our f in vector form. So that means we'll be having 250 sine of 10 in I direction plus 250 cos of 10 in j direction. So that means we'll be having f this, then we'll be having 0.4 in I direction plus, then for our j direction, 46.2 in j direction. As you can see, we've actually represent this particular force in vector form. So now the next thing we are now meant to do is, since we've actually identified this particular force, so let's identify our position distance. So that means our position distance will be in this particular format. Don't forget that this particular force is acting from A to B. As you can see, this particular force that we are given the magnitude is acting from A to B. So if we want to take the particular moment of this particular force, we will be having this going in this x direction and coming downward in this y direction to this particular point too. Because if this is the force, the line of action of this particular force is also in this same direction. And we know for us to get our position, we have to pick a point from this particular So that means for us to get the position of this is our point 2. So that means from this line of action, we can pick any point from this line of action, but we pick convenient point. As you can see, if we said we should pick point B, that means if we are picking point B, don't forget we don't know the magnitude of this B. So it will be very difficult for us. That's why I'm picking from point A to O. But if adding B, we are given this B, don't forget we have to also resolve this particular B into x and y component. But adding B we are given, we can actually use this. So but we are not given. So that is why I'm picking my line of action, and like the line of action that from this particular my points from A to O. My point from A to O. I point from A to O. So now how do I not go about this particular point? So that means I have to go in this direction initially, then also in this direction. Don't forget, if I'm going in this direction, I'm going towards the positive side, and if I'm coming in this direction, I'm coming towards the negative side. So let's write our R out. So that means we'll be having this. Then that means we'll be having going in this direction. Don't forget, the question is says from this particular point to this particular point is 235 millimeter. So let's convert it to meter. That's divided by 1000. So that means we'll be having 0.235 in I direction. And also coming downward in this particular aspect, that's minus 0.05 in J direction. So in this case, we know our moment in vector form. We'll be having our I, J, and K. So then we can write this out. We'll be having 43.4 in I direction, then 246.2 in J direction. Then for our K is 0. Then this will be having 0.235 in I direction. Then this minus 0.05 in J direction. Then this will also be 0. So that means we'll be having our moment about to be equals to. So now, if we pick our I, don't forget we are looking for this. So that means if we pick our I, we'll be having. So that means we are not picking anything here, This times this is 0. This times this is 0. So that means we are having 0 minus J into bracket. Also for J, we are not picking anything here, This times this is 0. This times this is 0. So for this is 0 plus K. So that means we are multiplying this by this, then subtract it from multiplying this by this. So that means we'll be having 0. We are multiplying this by this, then we subtract it from multiplying this by this. That means we'll be having 43.4 times 0.05. So that means we are having minus, don't forget it is minus 0.405 minus 2.17. Then minus, when we multiply 246.2 times 0.235, then we are having 57.86. So that means our moment about to is equals to this. Don't forget this is minus, so that means we'll be having minus, this is in K direction, plus, okay, sorry, this is 2.17. That means we're having minus 60 K. This is in Newton meter. So if we take the magnitude of N, the magnitude of this, so that means we'll be having our moment about to be equals to, this will be, since this is just alone, we'll be having 60 Newton meter. But don't forget, this our minus 60 meter is indicating it is going in clockwise direction, while this one is telling us it will be counter clockwise direction. So now, the other way in which you can solve this and you also arrive at the same thing is we use this particular force, which, don't forget, I use this. So while you can also try using this. So here is how you can go about this. You resolve this particular force into your x and y component like I did. Now the easiest way is, so that means don't forget this particular force here will be acting in this direction, also in this direction, So now if we resolve this particular magnitude of force into x and y component, so now the line of action of this force is here, the perpendicular distance to this center here, it is this. So that means you take this particular force in this direction. So that means we are going in the in the clockwise direction rather. So that means your force, this particular force, your Fy times the perpendicular distance here, which is in anti-clockwise direction, which will be negative. Then also this particular x force here times the the perpendicular distance here. So that means you will also be going in this also sense. Same thing, you are also going in the what? Clockwise direction. That means both of them will be what? Negative. Then you subtract, you add the two rather. You add the two together. Then you should arrive at same thing as this. But in another direction, that means it will be going in 60 Newton meter in what? In the counterclockwise direction. Make sure you subscribe to my YouTube channel and always turn on the notification button.